A big problem with infrastructure as code, such as Terraform, that gets introduced is you have something called drift. It means that your real-world infrastructure can change and it disagrees with your code, which is a big problem because your code is supposed to be single source of truth. So in this video, I'm going to show you how to make something like what you're looking at right now, which is automation. It's a pipeline that will automatically detect drift. You see here where it goes red? That means drift has been detected. You can see that, you'll be alerted, you can go remedy it and fix it because your real world infra should always match your code. I'm going to show you straight up now how to do this. One quick thing to mention, you should already be putting your Terraform code in a repo, and off of that repo you should already be deploying your Terraform using a pipeline. If you're not doing that yet, you're getting ahead of yourself. Don't worry about drift detection. Worry first about putting your code in a repo, single source of truth, and from there having a deployment pipeline. Only after that should you even think about drift detection. It'll be the least of your problems if you're not already doing those other two things. So for this to make sense to you, first I want to show you the Terraform code. I've got very simple backend and I've also got VPC. We're creating one resource. Let me show you real quick. So first, in terms of the backend, very simple. We're just saying that AWS is a required provider. We're storing our state in a backend S3 bucket, and we're using region US East 1. Very simple. And in the other file, vpc.tf, very simple. All we're doing is we're creating a resource. It's a VPC, nothing more exciting than that. And we have here a tag, and the tag is for a key of name. There's a value of main. We're actually going to change that as part of our drift detection. So next thing I want to show you is I want to do a plan to show you some of the output that we're going to be looking for in our pipeline. So let me run this, and you can see here that the state was refreshed, and then no changes, your infrastructure matches the configuration. So real world matches your code and there are no differences. Now as part of our pipeline, I'm actually going to use this part here and I'm going to have it test for a condition to do the same thing here. Run the plan, and if you see that there are no changes, and consider that to be no drift. However, if there's changes, it means that somebody behind the scenes has gone and changed the infrastructure. So the same code I showed you earlier, here it is in the repo. You can see there's the backend.tf, the vpc.tf. There's a readme, there's a git ignore, it doesn't matter. The key thing I want to show you now though is that there's also a directory called .github and then another one called workflows, and in there we've got a file called drift.yaml. This is how you define a pipeline on Github Actions, but it depends on which CI/CD solution you're using. So here's a YAML file. This is where all the magic happens. As I said, in Github Actions, the convention is to put it in .github/workflows and then call it whatever you want, .yaml. And here we are. First of all, we've got this defined on workflow dispatch. This means that I can actually trigger this manually, which we're going to do. But eventually, what you probably want to do is consider having this run periodically, automatically on a cron. So for example, every 5 minutes, which is the most frequent you can have on GitHub Actions, you can define it like this. One reason against doing it like this is that there's no guarantee of timeliness when it comes to using GitHub Actions and cron. But to be honest, you're not going to be running every 5 minutes eventually. You probably run this maybe, I don't know, once an hour max, maybe even just once a day might suffice. So when you're ready, you can comment out this workflow dispatch and you can replace it with this schedule cron. Now, first of all, we need to define some environment variables that we're going to be using because we have to authenticate to AWS, of course. And also when we do a Terraform init, we're going to need the backend bucket. So I've actually defined already 3 secret repository variables. You do that in GitHub Actions just by going to your repo, go into settings, scroll down, and you can see a function to be able to store secrets. So that's what I've already done. And when this pipeline runs, first thing it does is it sets some new environment variables that are equal to the secrets that I already set. Now here we go. There's only one job. It runs on the latest version of Ubuntu. First thing it will do is check out the repository, so it will clone and get the code. Then it'll set up the AWS creds that are going to be needed. So here it's just going to export the what we had here in the environment variable from here, which was loaded from here. is going to do export AWS key ID equals that, secret access key equals that, and the default region equals US East 1. To be honest, I've kind of repeated myself here. I'm not sure. I don't actually think this was actually needed, but this last part here was. I just scroll down and then set up Terraform. This actually uses a predefined vendor task, which is pretty cool. You get that on a lot of CI/CD. So here I just have to say HashiCorp set up Terraform and specify the version. I don't have to do a wget to download the zip file, unzip the zip file and all that kind of stuff. All you need to use is just use this. Very easy. And now let me just close that. I just clicked it and I opened it handily, and here we go. Now we got another one called Terraform init. Backend config is the bucket that is our environment variable. Remember that. This way I don't have to store my state file bucket in my code. I don't have to store it in this YAML or even in my Terraform code, which because of course it's sensitive. So that's why I've used a secret variable. And then we go Terraform plan. Create a plan. This is the file name, TF plan. And here is where the magic happens. We've got an if statement and two things can happen. So a Terraform show TF plan happens, and it's then grepped. And if it finds no changes, which remember we saw earlier on the command line, then it's going to echo a message, drift detector, no changes detected, no drift detected. So that's great. But if it doesn't find this no changes, and when might that happen? That might happen if it sees a difference and it wants to try and correct it. Then we're going to get this message instead. Drift detected, your code and real world infra do not match. Exit with an error code of 1, and that will fail the pipeline and give us that red X, which is what we've been looking for. And here's just a reminder what I was talking about. There is that no changes. So if we run the pipeline now, it should look the same when the Terraform plan is done, and also it should see that. So let's do that. And by the way, we could have just run this grep off of this Terraform plan, but this is kind of a nicer way to do it, to actually create the plan and then show the plan and run this. It's a slightly nicer way to do it, to do all the hard work, all the compute up front, and from there we can then use TF plan and do what we want. And if you want to take this further, you can even use a JSON parameter on here. You can extract various values and stuff like that, but we're not going to do that. So here we are, we're in Actions, and I've clicked on here Terraform drift detection, and I've then clicked here run workflow, and I'm now going to click on this green button, run workflow. And it says here that the run was successfully requested. Usually got to refresh the page to actually see it, so let's do that. Oh, there it is, it's just appeared. So let's click on that. And there it is running, so let's click on that. Oh, and actually it's already gone green, which is good, which is great. But let's click on it to inspect it. And here you can see all the steps that were executed all successfully. I'm going to open the one that we're interested in, which is Terraform plan. And here we go, and you can see that it ran the Terraform plan. It created the same output that we had earlier, and line 22 is that if statement where it actually does a show the TF plan and look for no changes, and if you find it, then just say no changes detected. So that's great. It followed the logic that we wanted. Now here we are in AWS, and I mentioned I was going to change a tag, so I'm going to change this tag now. There's nothing special. I've just renamed it some new tag. I'm going to save that now. And now just to demonstrate, I'm going to run this plan again. And you can see that it's detected that there's a difference compared to the code. So it's actually seeing that it's called some new tag, and what it wants to do is it wants to change it back to main, because main is what the value of the tag is in the code. So I'm not going to go ahead and apply, but I just wanted to demonstrate to you that the plan now looks different. And notice it doesn't say no changes. In fact, it says stuff like execution plan, update in place, will perform the following actions, etc., etc. Now, I'm not looking for those keywords in our code. The only thing I've said is if it doesn't say no changes, then you should assume that there are changes. So let's go run that pipeline again. Here we are again as before. Let's hit run workflow, that green button. There we go, it's running again. There it goes. And we're still at the top level, and as you can see, it's gone red. We got a red X now. So if you think about it, if you're in the workplace, you've got this drift detection set up. If it's running once an hour or once a day, you would expect a whole load of green. But if you see red, it means you need to act. You've got drift. So I've just opened up that failed pipeline, and then here, drift detector, drift detected. And this is because it didn't see no changes. Your code and real world infra do not match. Exit with a code of 1, and that's what caused. And if you want, you can imagine that you've just discovered that you've got that drift, and you see that the tag has been changed by someone else, and then of course you can just go ahead and just correct it and apply the plan, and it should revert the tag back. There you go. Us as the engineer, we've just done the apply, we've put it back, everything is back to what it was. And if we want to, we can either run this pipeline again, or it'll run again soon enough because it should be being run periodically. But I'm going to force it to run anyway, so here we go. It's running, it's in progress. And there we go, it's now back to green. Everything is back to normal. So this is a very rudimentary drift detection pipeline. And before we go, I just want to show you something here. So we're using Terraform show TF plan, but you can do this in a more advanced way. Let me show you something. So this is the command I just copied and pasted, and if we do this, put a JSON switch in there and then pipe it through JQ, which is installed by default on GitHub runners, then we get something like this. And we get a very long JSON file. It's a bit like Kubernetes. When you run Kubernetes commands, you typically get shown a table, but actually behind the scenes, if you want to see the full JSON, there's a lot more info that you can get. Now I'm only showing you the end of this JSON file because it does contain some sensitive details in here that I don't want to share with you, but my point is that if you run that command but you run it with the JSON and then you use JQ, you can potentially programmatically interrogate any part of the JSON document that is actually part of the plan, which is a lot of people don't realize that. So there's a lot of possibilities here. I've only shown you with this an extremely rudimentary way to do drift detection, version 0.1 if you like. You can make it more robust, do much more powerful things that are going to fit with what you and your organization might be looking for. So I hope you found this interesting, drift detection on a very basic level. Let me know what you think, leave a comment, give this video a like if you enjoyed it. I will see you again soon. Take care, bye bye.